Hello, how are you? Welcome back. Uh, we continue our discussion in work and energy, but if you recall in my last class, I tried to give you the concept of conservative and non-conservative forces. And I did go slightly beyond your syllabus. Generally, these things are covered in engineering or higher physics or high mathematics. But there is a reason why I talk about this, because if you make use of some of these partial derivatives, then it becomes very easy for you to look at some of the problems of physics. So when physically you say that some force is conservative, some force is not conservative. I told you, physically, how do you get that? See, physically, if the force is operating and the work done by the force, if it doesn't result in conversion to thermal energy, then mostly we call that the force as conservative. Not a definition, mind you, not a definition. But mathematically, if you go, I just want to recall those two parameters. One is the conservative force and the second is the potential energy. I just do that. I know that I gave in great detail last time, but I do give it again because this is a very, very important concept. If you're going to apply this even in electrostatics, you get the point? So let us now see what I was trying to say. If force is conservative, if force is conservative, then del cross F must be 0. This is curl of F must be 0. And if any curl is 0, then F is expressed as any scalar, gradient of any scalar. Now this is del cross F, this is grade phi. Of course, you will understand these things much later, but I am not interested even if you don't get it. But I am going to write this as, this is the meaning of it, so that you won't have any confusion. Plus or minus this, then F is expressible as this. And when I am talking of force, phi is called potential energy. If it is not F, something else, maybe, I don't know, maybe E, then if curl of E is 0, then E is equal to plus or minus grade phi. This is important. It all depends on this relation between these two. But the moment I talk of F, this is bound to be potential energy. And that is why this is possible only if the force is conservative. So what is the condition for the force to be conservative? Curl F must be 0. Curl is a concept beyond your comprehension at this stage. But what this actually means, I'll give you. I told you dou Fx by dou y is equal to dou Fy by dou x. If they give F as an xy function, or dou Fz by dou y is dou Fy by dou z, or dou Fy by xy, yz, zx. I think Fy, xy 2 times, dou Fz by dou x is equal to dou Fx by dou z. If this is the meaning of curl F0. So generally in all our problems, what they give is F they give as a function of xy. or yz, then use this. This is a very important concept for you to prove mathematically that this is a conservative force. Okay? Now, what exactly do we mean by this? I just take an example. I fx plus jfy plus kfz. This is a well-known thing for us. Now I am giving if f bar is equal to ix plus jy. Some function, force is a function of x, the position x and y is given. Now is this force conservative? So it is in x and y. If f is equal to fc, then what you should prove? Dou fx by dou y is dou fy by dou x. This is the thing that I have been telling you. Okay? Now, how do we take it? What is fx here? X. What is fy? Y. So, dou by dou y of x. What is this value? Now, if you are aware of the partial derivatives, it's no problem. Otherwise, I tell you, it's a very simple, it's ordinary derivative. If you talk of y, any other parameter is treated as constant. For example, I want to know x squared y. Dou y of x squared y is how much? Generally, x is a variable, but when you say partial derivative, except y, all others are kept constant. So, x squared becomes constant, then dou y of y, 1. So, answer is x squared. Suppose I say dou y of xy squared. What will be the answer? Partial derivative with respect to y. Only y is to be differentiated. Y, the other parameters are kept constant. So x is constant. X as it is, y square is 2y. That is 2xy is the answer. So differentiate with y, same. All others you keep them as constant. Okay? Got the point? It is not only with respect to y, with respect to x you do the same thing, with respect to z you do the same thing. Now dou x by dou x is constant, constant derivative with respect to y is 0. What about this? Dou fy is y, isn't it? So, dou y by dou x, isn't it? Because dou by dou x of y, and as far as this parameter is concerned, y is constant because you are differentiating with respect to x. Therefore, this is 0. That means both are same. So this is valid. Therefore, f is equal to fc. Alright? Now what I do here, I give functions and C or not, conservative or not conservative, and I am giving f. First I have given ix plus jy. Ix plus jy is a function of x and y. So is it conservative? Yes, it is conservative. You got the point? Because I have proved it. I give this is first example. Second example, iy plus jx. Is this force conservative? What we should do? It is an xy plane. So, differentiate the first parameter with respect to y, second parameter with respect to x. Now, y dou fx by dou y, dou fy by dou x. This you always remember. Now fx, what is fx? Y. So, dou dou by dou y of y is how much? Similarly, what is dou x by dou x? 1. So both are same. So what do you mean by this? This is also a conservative force. First I will prove which are conservative, which are non-conservative. Then only I will go into the other things. Okay? Alright. Next. The third one I would say for example only Ix. So because Ix means J 0, that's how we should have it. So dou fx by dou y. Dou by dou y of x is 0. This is anyway 0. Therefore conservative. Suppose Iy, there is nothing there. What about this? See, dou by dou y of y, this is 1 and this is 0. These two are not one and the same. So, non-conservative. All this is mathematically done. Do you understand? If I give Iz, then also, what is Iz? Let us not, I think, get into jet level concepts. I think that will be slightly more for you. Ix square y plus jy square x. Suppose that some function is given. What is fx here? Fx is x square y, fy is y square x. So dou fx by dou y is x square. Dou by dou x of y square by x is y square. So this is not equal to this unless x is equal to y. Only at that point. But that's not our concern. Therefore, this is a non-conservative force. I hope you are able to follow this. Then I slightly give differently xy square plus j yx square. Then what happens here? If you are interested, I will extend this for you. Fx Fy, so that you don't have any problem. Fx is x, Fy is y, this is y, this is x, this is x, 0, y 0, x square y square x, and xy square yx square. I have given you another form. Now dou fx by dou y, dou fy by dou x. So that all parameters are given in this tabular form so that you can have a ready reference. So what is this with respect to y? 0. With respect to x, 0. Both are same or not? So conservative. And with respect to this is 1. Isn't it? Y with respect to y, 1, x with respect to. So this is x with respect to x is 1, this is 0. So, no, sorry. With respect to y, this is 0. And this other one is anyway 0. Therefore it is conservative. Now come to this. With respect to y, this is 1. With respect to x, 0. Because these two are not same, it is non-conservative. Then what about this? This with respect to y, x square. This with respect to x. y square. So these two are not, both are xy, both are x square, both are x, then it is okay. But this is not. Then let us see. Fx xy square. What is this? Dou fx by dou y. X constant, y square is 2y. So 2xy. Alright. Then yx square with respect to x square, 2x into y. So these two are same. So this is a conservative force. Now I am going to the 7x. I think I will draw a line for you so that you won't have any problem at any stage. This is very, very important, my dear friends. Okay? All right. Okay. Now, I take this x square y cube plus j y square x cube. So x square y cube, and this is y square x cube. Now this you have to differentiate with respect to y. So what do you get? 3y square x square. This you have to differentiate with respect to x. 3x square y square. Look, both are same. Therefore, it should be a conservative force. Now, suppose if I give ix square y cube minus jy square x cube, same as this but a negative sign. So, what do I get here? This is minus y square x cube. X cube, this is plus x. So what do you get? Dou fx by dou y. So 3y square x square. This is plus, this is minus, they are not the same. Therefore, this is bound to be non-conservative. I hope now you are getting the concept behind it. I'll just give you x cube y raised to 4 plus j y cube x raised to 4. Then what's going to happen? First of all, fx x cube y raised to 4 y cube x raised to 4. Now tell me what are you going to get? This you differentiate with respect to y, 4y cube, because x is kept constant. And this one, 4x cube y cube. Wow. These two are same, therefore this is a conservative force. That's how you have to do. And finally, probably, because let me complete this figure. Ix y raised to 5 plus jy x raised to 5. Now you can easily say whether it is conservative or not. How? Fy, that is yx raised to 5. And this is x y raised to 5. Now this fx with respect to y, this is 4y raised to 4x, and this is 4x raised to 4y. So these two are not the same, therefore they are non-conservative forces. Whenever they give in this fashion, you can immediately work out and say this is a not. Now, just like that, I'll go to next case, 11th. If I go to the 11th case, 2yx plus jy. So, what are the things? y, this is 2x. Is it conservative or not? Because I don't know what we did with respect to y. With respect to y, this is 0. With respect to x, this is 0. Therefore, this is conservative. I go to another one. Maybe I take 2 here. This is 12th example. So this is x and this is 2y. And this is with respect to y. So what is that answer? 2. This is 1. So non-conservative. See, this is going to make all the difference. When I keep 2, 3, it's not going to make any difference here. But if I keep those constants, so be careful. The plus minus sign is important. And the constants are important. Everything you have to take and say whether it is conservative or not. So now you have got all these cases. I hope this is clear to you now. See, one is how to get the force to be conservative physically. In general, wherever that work is performed by such a force, if it results in, say, generation of thermal energy, then you take it as non-conservative force. Kinetic friction is the best example. Try to do like this. I know this will be lukewarm. You understand my point? Therefore, that is physical way of doing it. When you go with mathematics, no clue. So I gave you, this is how you have to go about. I hope this is clear to you. It is better that you work these things out on your own, and that will be very much helpful. Okay? Now, I am erasing this part. I want to retain this because probably, what is this? Ix plus jy, then 2 is Iy plus jx. This is also conservative. All 12 are, of course, not in order, be careful. Maybe I will erase this here, and as usual write 2 Iy plus jx, and 1 is Ix plus jy. So this is conservative and this is non-conservative. 12. Plus jx. So I have given you virtually 12 models. Now, let us see one important thing of how to get the work done with this kind of a force. When say this is, remember this displacement is in a plane. Suppose if it is not in a plane, look at 3. Look at 3. What does 3 say? Ix is directly proportional. It's equal to x. So F is equal to x. Okay? What is work done? dW is F dot dr. dW is F dot. What is dr? Remember, F bar is alpha x, jfy, kz. R bar Ix plus Jy plus Kz. This is the Cartesian coordinate system. So we take x, y, z, and of course wherever z is not there, we simply don't take it. And what is dr? Always I dx plus j dy plus k dz. Remember these three things always, okay? Now f is x only, ix, only this I, these two won't be there. So dr is simply dx. What do you get there? So integral dw x dx, y ix dot I dx. So I dot I1 x dx. This is x squared by 2. You have x1 to x2. This is w. If you take it from 1 to 2, x2 squared minus x1 squared by 2. This is very important. In one day, this is how you're going to get. Okay? Is that fine? Right. Look at the third example. Look at example number 4. What is the work done you got in this case? X2 squared by 2 minus x1. What is 4? Iy. Okay? That means Iy dot, what is dr? I dx plus j dy. This is how you are going to get. And you know I dot j0, I dot I1, you will get integral y dx. This is how. And you know very well this is not possible for you to work out what is the work done unless it is specified. What is? So y and x, either y, if it is constant, then you can do something. But y is a variable, you want to get the integral of y dx. Not possible to work on that, okay? Yeah, but still, you can give some value there and find out. Say y is equal to some 5 or y is equal to x. So you go along y likewise. I'll tell you how to do that. For example, if I give you now, let us now go to the first example. What is the first example? Ix plus jy. Ix plus jy. And dr is equal to I dx plus j dy. I will tell you how to get the work done out of this in two ways. One, first of all, do it. dw is ix plus jy dot I dx plus j dy. So you got x dx plus y dy. Now w is equal to this. Now I can write this as x dx plus y dy. How do you get that? X squared by 2 plus y squared by 2. And substitute. Say x1 comma y1. So you take from x1 comma y1 to x2 comma y2. Whatever be the path, you directly substitute, you will get the answer. What is that? X2 square minus x1 square plus y2 square minus y1 square by 2. So no matter how you go from 1 to 2. But if you go every time, This is the answer. But if you know, say 0, comma 0 to 3, comma 4, substitute. You will get the answer. 3, comma 4, you will get it. Okay? Now I will tell you the same thing. Integral x dx, this is what we got. Now, I want you to go from 0, comma 0 to 3, comma 0 to 3, comma 3. This is the path I have given. I am just showing it here. 0, comma 0, 3, comma 0. This is the first path. Second path is x is 3, 0. X is constant. It will go to from 0 to 3. So this is 3, comma 3. This is the path. How to get the work? Now I tell you. How to get the work? Right. First of all, you have to perform these integrals along path number 1, path number 2. Path 1, perform these integrals. Path 2, perform these integrals add. Path 1, what are the limits? 0 to 3. Right? Along path 1 equation, along this, that is x-axis, equation is y is equal to 0. What is the path along this line? That is x-axis. Therefore, y is equal to 0. If y is 0, dy is bound to be 0. You understand? So, x is a variable. So, I can't disturb it. So, if I substitute, this is integral x dx plus 0. Because y dy is 0. You get the point. And what is this? This is simple. X is varying from 0 to 3. So, what am I getting? X square by 2, that is 3 square by 2, 9 by 2 is the answer from here till here. That is the first part is done. What about part 2? Every time the problems are given, you better take part 1 separately, take part 2 separately, work out, and this is how you better do it. There are techniques. Without doing this also you can do. But I want you not to get into such kind of things in the beginning. The path, each path you identify and then tell me what is the work done in each case and then add up. Plus, 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 minus, minus, plus, both minus, it doesn't matter. So along this, what is the path? 0 to 3, 0 to 3. And what is the path 2? This line equation is x is equal to 3. So I am writing here. So the equation is x is equal to 3. Therefore, dx 0. So if I substitute this becomes 0. Then what is this? Integral y dy, which is y squared by 2, 0 to 3. And if you substitute, so 9 by 2 plus 9 by 2, total work done is 9. In the previous case, without looking at the path, what did you get? x2 square minus x1 square plus y2 square. What is x2? 3 square. 9 minus 0 plus 9 by 2. So 9. Without knowing the path, you got that answer. By specifying a path, you got the same answer. Not over yet. So I have shown you here without path, what answer you got? With path bottom, so you have got first path I have given, I will write it here, 3, 0 to 3, 3. Now 2, I will go now 0 to 3 and this is 3, 3. So what are you going? 0, 0, 0, 3. How are you going? 3, 3. How do you write this? X is equal to 0. And you write y is equal to 3. Very simple. Along path 1, x0, x0, dx0. Therefore, first integral vanishes. Integral y dy is y squared by 2 and varies from 0 to 3. So 9 by 2 is the answer. And go along y is equal to 3. Y is equal to 3, dy is 0. So integral x dx is x squared by 2. 0, 3, 9 by 2 plus 9 by 2, 9. Second path also you are getting the same answer. Fine. Okay? Now, I want you to go direct. 3, 3. These are all straight paths. That means what? Now you have to get what is the path here. How do you get the path? dy by dx, that is the slope, is this opposite side by adjacent side. So 3 by 3, 1, or dy is equal to dx, or y is equal to x. Because it is passing through origin, you won't get any constant. This is the equation. Y is equal to x. Therefore, dy is dx. So, you have integral x dx plus integral y dy. You can write x is equal to y, though this becomes y dy plus y dy. So, what is the answer? 2y dy. Integral. Y varies from 0 to 3. So, this is y square by 2. By 2 gets cancelled. So, the answer is 9. Now, I want you to watch this carefully. I have taken without the path I am able to do because that was an exact differential. Because that was an exact differential, number 1. Number 2, when I am choosing any path, I am getting the same answer. And this is a conservative force. What we took was a conservative force. The consequence of now, conservative force is that the burden is the path independent. It doesn't depend on the path at all. You choose any path, but your initial point and final point must be the same. So as long as your displacement is same, you don't bother about the path through which the body is taken from the original position to the final position. Many people give this as the definition of conservative force. Not true. But yes, if it is so, definitely there is a conservative force. But that is not the definition of conservative force. You understand? I said gravity is a conservative force. Now, for example, I take one body from here till here. Right? I know here, I know here. I know how much is the work. That is straightforward to find it. Now I take this body like this and then bring it here to that position. It makes no difference. Because what counts here is initial and final position only because gravity is conservative. And in this any path you choose, you are going to get this. Now I will tell you, sometimes when they say This is the path. You don't even know how to get this path. This is spiral. This is X, this is Y. Very difficult for you to get this spiral equation. It's beyond our knowledge at this stage. But then why did he give like this? You should understand that this force is a conservative force. This is path independent. Therefore, you choose your own path. Work done will be the same. So I have already chosen this. What is that work done? 9 only. This is only to confuse you, they give. They give some zigzag fashion. I am giving you a spiral. I might give you like this. This is 0, 0, 3, 3. The path K can go and come like this. It makes no difference to us. We are least bothered about the path because as long as the final and the initial positions are known, you can directly find out the work done provided force is conservative. But I'm not going to leave it here. I'm going to work out the problems with the help of other things also. We will do 2 to 3 examples. I want you to be absolutely familiar with this kind of a thing. In each of these cases, we can even find out what is the potential energy, etc. That also we will deal with, right? Now try to have practice of this. In the meantime, try to work out these things on your own. And when I work out next time in the class, I want you to verify whether what you got is right or wrong. Okay? So thank you. Bye.